This is at THS Mr. Jones with Chapter 4.5, Complex Zeros. And our objective here is to factor polynomials with real and complex zeros. So in Chapter 4.4, we solely worked on real zeros. Okay, and now we're going to combine in Chapter 5, we're going to combine these real zeros that we have found with our complex zeros. So the degree of the polynomial tells you the number of zeros slash factors, zeros and factors and roots are all the same thing, that you're looking for. So the complex conjugate zero theorem is super important, okay? And this will trick you up all the time. So if a plus bi is a zero, then a minus bi is also a zero. Okay, they have to come in pairs. Okay, just like if you were noticing when we did the our plus minus I t chart, which we'll do again in this section. Okay, this column right here, wherever these i's were, was always an even number. Okay, no matter what it was, 2, 4, 6, always an even number. These out here could be odd, but that I column was always even. Why? Because I have to have both the positive and the negative. Got to have the conjugate. So find the zeros of x squared minus 4x plus 13. Now you can think of, are there factors of 13 that add to 4? No, there's not. Okay, so this will be a complex zero. And excuse me, we really don't want decimals in this. Okay, so how could I find the zero of this? Well, that's simply the quadratic formula. Which we all should know, the quadratic formula. Okay, this is A, B, and C, and we're just plugging it in. So negative B, so that's 4 plus minus the square root of B squared, so that's negative 4 squared, so 16 minus 4AC all over 2A. So that's 4 plus minus, get your calculator here to assist you with this. 4 times 1 times 13. Square root of negative 36 over 2. The square root of negative 36 is 6i. So you have 4 plus minus 6i over 2. And everything can be reduced by 2. So we've got 2 plus minus 3i. And those are our zeros. So x equals 2 plus minus 3i. Now those are the zeros, but what would the factors be? Well, if I wanted to factor this up here, I would say that x minus 2 plus 3i and x minus 2 minus 3i. Those are my factors. And you'll see some people write it like this: x minus 2 plus 3i, x minus 2 minus 3i. I don't care which way you do it. Okay, doesn't matter to me, but you will need to know how to write those as factors. So find the minimum degree polynomial with zeros given. Okay, so we did this a couple sections ago. Okay, and if those are my zeros, we'll say that x equals negative 2, x equals 1 minus I, and x equals 1 plus I. You have to make sure here that you've got your conjugate, though, which I do. Okay, so now we'll say x plus 2 is one of my factors. Then we can say x minus 1 plus I, x minus 1 minus I, like so. And now all we have to do is multiply it all out. Okay, so we will save this one, x plus 2. Okay, and now I've got 1, 2, 3, 1, 2, 3 terms, so I just multiply them all out. So I've got x times x, x times 1, x times negative I. Move to the second one. So negative x plus 1 plus I plus xi minus I minus I squared. So kind of long there. Remember, we're just distributing everything, or if you want to stack it up on top, you can. Doesn't matter. So combine like terms. We should have some things cancel out here. So my minus xi plus I minus I. My I squared is negative 1, so this becomes a plus 1. So let's see what we have here. X plus 2. I've got x squared minus 2x plus 2. Okay. And then we'll just take this and distribute that in there. So I get x to the third minus 2x squared plus 2x. Move to the next one. Plus 2x squared minus 4x plus 4. Combine like terms, I get x to the third. That cancels with that. Minus 2x plus 4. And then there's our polynomial. Okay. So be careful with these i's. Make sure we just move them over to the other side, set it equal to 0, and then be very careful in our distributing. Okay, so factor the polynomial that given I is a 0. That is super important, because if I is a 0, so if x equals I, then x also equals minus I. Those have to be both zeros because the complex conjugate 0 theorem. Okay, if I is a 0, then negative I is. So here I have x minus I, x plus I. So if I FOIL that out, I get x squared plus xi minus xi minus I squared. That cancels and that cancels. I squared is minus 1, so this becomes a plus 1. So you have x squared plus 1. So this is a factor. Now, how do I factor that out of this? Well, I cannot use synthetic division because it is not linear. Okay, so we have to do long division. So I got x4 minus x3 minus 5x squared minus x minus 6. So this becomes x squared. Take that times all this. So x to the fourth plus 0x to the third plus x squared. Subtract. Those cancel. Negative 1 minus 0. That's minus x to the third. Negative 5 minus 1. That's minus 6x squared. Bring down your next term. Here we'll have minus x. So you get minus x to the third plus 0x squared minus x. Subtract. These cancel. You get minus 6x squared. Those cancel. Plus 0x minus 6. So then we've got a minus 6 here. Again, take this times all these over here. We'll have minus 6x squared plus 0x minus 6. And we should get a 0 as a remainder. Why do I get a 0 as a remainder? Because we said that it was a factor up here. It told me it was a 0. Okay, so we've got our x squared plus 1, x squared minus x minus 6. Now, I need to factor this one right here. So what are factors of 6 that subtract to 1? 3 and 2. Signs are different. The bigger one is minus, so minus plus. Now, I can factor this right here. We just had it factored up there. So I will write x minus I, x plus I. And now we are completely factored. This is important right here. That's our goal. That's what we want. Okay. And if we check it on the graph here, x to the 4th minus x to the 3rd minus 5x squared minus x minus 6. If we just quickly look at the table here, look what happened when I plugged in 3. I got a 0. And when I plugged in 2, I also plugged in minus 2. I got a 0. What happens if I plug in I? Oh, we're not in that mode. If I plug in I, it's not going to let us here. Okay. If I were to plug in I and negative I would also get a 0 there. Okay, they would cancel out. All right, so that's kind of our goal of what we're going to. Not always will I give you this initial part up there. So let's try another one. Factor if 1 plus I is a 0. Well, if x equals 1 plus I, then x also equals 1 minus I. So then we got to multiply these together. So I have x minus 1 plus I. I'm going to do this just a little bit differently. I have x minus 1 minus I. Let's not do that. I don't want to confuse you. So x minus 1 minus I and x minus 1 plus I. Okay, so now we just FOIL these out. So I get x squared minus x plus xi minus x plus 1 minus I. Go to this one, minus xi plus I minus I squared. So this one and this one cancel. This one and this one cancel. And this becomes a plus 1. So I have x squared minus 2x plus 2, which I think we did just a little bit ago. Okay, so now I'm going to take this and pull it out of this polynomial up here. And I have to do that with long division. So I have x to the 4th minus 2x to the 3rd plus x squared plus 2x minus 2. Okay. Now remember this part right here, because that's going to be our factors later on. Okay, so I've got x squared. So I have x to the 4th minus 2x to the 3rd plus 2x squared. Subtract, those cancel. These cancel, and you get 1 minus 2, so minus x squared plus 2x minus 2. So then we've got x squared to become minus x squared, that's minus 1. So you have minus x squared plus 2x minus 2. Subtract, cancel, cancel, cancel. Why is it cancel? Because over here I said that it was a factor. So then I have x squared minus 2x plus 2 times x squared minus 1. Well, this factor came from over here, okay, right here. So we'll say x minus 1 minus I, x minus 1 plus I. And now tell me how this one factors. We should know how to do that one. That's just a difference of squares. X plus 1, x minus 1. So this polynomial right here is the same thing as that polynomial right there. Just factored out completely. These are your reals. These are your imaginary because I got an I in it. So let's just review the plus minus IT chart because now we're actually going to get used to the I column. So we want to look at f of x sign changes. So that first one is a plus, a minus, a plus, a minus. So that's 1, 2, 3 sign changes. So I got 3 or 1. You go down by an even number. If we look at f of minus x, we talked about how only the odd powers change. So this was positive, now it's negative. Even doesn't change. Odd changes, so it was negative, now it's going to be positive. 2 doesn't change, and the 5 doesn't change. So I have 1, 2 sign changes or down by an even number. So we got plus, minus, I, t. So for positive, we had 3 or 1. For negative, we had 2 or 0. A total will be your highest exponent, so 5. So here I could have 3, 2, 0 imaginary for a total of 5. I could have 3, 0 here, 2 imaginary for a total of 5. Again, we're doing all the combinations of these numbers. Now I can have 1 here, 2 here, 2 here for a total of 5. And here I can have 1 here, 0 here, 4 imaginary, again for a total of 5 zeros. Over here in this one, so f of x, that's positive, positive, minus positive. So that's 2 or 0, 1, 2, or down by an even number. F of minus x, this one doesn't change. This one changes to a negative. This one changes to a positive. And this one stays a positive. So that's 1, 2 sign changes. So 2 or 0. So we have plus, minus, I, t. Total of 4 here. So we'll put a little 4 up there. 2 or 0 there. And 2 or 0 there. I just get those numbers from over here. So I could have 2, 2, 0, 4. I could have 2, 0, have to have 2 there for a total of 4. I could have 0, 2, 2, 4. And I could have 0, 0, all 4 imaginary for a total of 4. Okay, super important. Tells me how many positive, negative, and how many imaginary zeros that I'm looking for there. All right, let's look at one here. Factor. Okay. Doesn't give me any zeros or nothing. So we will start with the plus minus IT. So P of X equals positive, positive, negative, negative. So that's one sign change. P of minus X, let's see, that will turn to negative. That will stay positive. This will turn to positive, and that will stay negative. So that's 1, 2 sign changes. So that's 2 or 0 negative. So plus minus IT. So that's 1, 2 or 0, and a total of 5. So I could have 1 here, 2 there for a total of 5. I could have 1 here, 0 there, 4 there for a total of 5. Okay, and that's all the combinations. Next, we want to look at P's and Q's. My P is 2. My Q is a 1. So that's 1, 2 over 1. So plus minus 1, plus minus 2. We got to figure out which ones work. So if I plug it in here to the calculator, x to the 5th plus 2x to the 4th minus x minus 2. If we look at the table here, I got a 1 works. So we'll take a 1 with synthetic division. So that's 1, 2, that's a 0 for the third, a 0 for the x squared, minus 1, minus 2. So we get 1, 1, 3, 0, 3, 3, 3, 3, 3, 2, 2, 0. Okay. We got a minus, we got a minus, see 1 worked here on my table. We got a minus 1 here, gives me a 0. So we'll come right here and we'll do a minus 1. So that's 1, negative 1, 2, negative 2, 1, negative 1, 2, negative 2, 0. What else? We had a negative 2 worked down here. Minus 2. So that's a 1, minus 2, 0, 0, 1, minus 2, 0. Okay, so let's see what we got here. We've got these factors right here. So x minus 1, x plus 1, x plus 2, and what was left here? This was constant x squared. X squared plus 1. Now, I have to factor this portion right over here. Okay? So the way we're going to look at that is as a difference of squares. I want to make that a difference of squares. In order to do that, I have x squared minus negative 1. Okay. Now remember, when we factor that, it's the square root of this one goes in the first spots. So x and x. We have a plus, we have a minus, and it's the square root of this one that goes in these spots. Well, what's the square root of negative 1? That would be I and I. So this here factors as x plus I, x minus I. And then we've got our other factors, x plus 2, x plus 1, x minus 1. And there's our factors. How could I factor that without knowing that? You can simply use the quadratic formula if you would like to look at that. Okay, let me do one more here that might be a little more tricky. Okay, again, we look at our positive and negatives. So that's positive, negative, positive, positive, negative. So that's 1, 2, 3, or 1 positive zeros. So that's 3 or 1. So this one, if I plug in negative x, this stays the same. This changes to a positive. That stays a positive. That changes to negative, and that stays negative. So then I have 1 negative, and I need 4 total. Okay, so I could have 3, 1, 0 for a total of 4. I could have 1, 1, 2 for a total of 4. And that looks like it's all my combinations. So then we'll go P's and Q's. P is 26. Q is 1. So I need all my factors of 26. So that's 1, 2, 13, and 26 over 1. So that's plus minus 1 plus minus 2, plus minus 13, plus minus 26. So now we've got all our possible ones. We'll go in here and we'll graph it. And I like to use the table to kind of narrow down the zeros I'm looking for. So if I go to the table, okay, so 1 works. So 1 is going to work. So we've got 1 minus 5 is to the third, 5 squared, 25 minus 26. So 1, 1, minus 4, minus 4, 1, 1, 26, 26, and 0. Okay, looking down here, okay, minus 2 works. So minus 2. So that's a 1. That's minus 2, minus 6, 12, 13, minus 26, 0. So I got 1 minus 1, 2 minus 2, 13 minus 13. Those didn't work. 26 and minus 26. Those didn't work. Look what we got here, though. Constant x squared. So I've got x minus 1, x plus 2, and I have a quadratic. Okay, how can I factor the quadratic? Well, we'll use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So that is 6 plus minus the square root. Let's see, 36 minus 4 times 1 times 13. That's minus 16 over 2. The square root is negative 16. 6 plus minus 4i over 2. Those are all divisible by 2, so we have 3 plus minus 2i equals x. So then my factors there, okay, so we bring down these factors. We got x minus 1, x plus 2. Now I got to move the x over. So we'll say x minus 3 plus 2i and x minus 3 minus 2i. Okay, so we're trying to get this synthetic division down to a quadratic, and then we can use the quadratic formula. Here's your suggested problems for 4.5. Okay, got a few of them here. Make sure we understand the examples, come into class, and be ready. 75, there's a challenge problem. Come into class, be ready to discuss this in some more detail. As always, thanks for watching. This is @THS Mr. Jones signing off.